Okay, Pythagorean's theorem tells us that the sum of the squares of the legs, the sides touching the right triangle, is equal to the sum of the hypotenuse, the side opposite the right triangle. So 3 squared plus 4 squared is equal to c squared. 9 plus 16, so 25 is c squared. That means that c is equal to the square root of 25, which is equal to 5. Okay, here's the legs. So 5 squared plus 12 squared is equal to the square of the hypotenuse, which is this. 25 plus 144 is c squared. So that means that c is equal to the square root of 169, which is 13. Okay, the square of the sum of the legs, so b squared plus 4 squared is equal to the square of the hypotenuse. So b squared plus 16 is equal to 144. That means b squared must be equal to 144 minus 16, which is 128. So b is the square root of 128. Now, this is not a perfect square, so it can't come out, but 64, which is a perfect square, is a factor of this. So I can rewrite this as the square root of 64 times 2. And then you can take out the 64 by square rooting it, and it becomes an 8. So this is equal to 8 root 2. Now, if you didn't see that 64 was a square factor of this, you can just start factoring 128. So another way to do this is to factor 128. This is 64 times 2. Now if you see it, you can just jump right to that. But let's say you still didn't see it. Make this a 32 times 2. Make this a 16 times 2. 8 times 2. 4 times 2. And 2 times 2. So we have 2 to the, let's see, 1, 2, 3, 4, 5, 6, 7. So we would say that this is equal to the square root of 2 to the 7th power. But 7 is not divisible by 2, so this would be equal to the square root of 2 to the 6 times 2. And you take this out, and you get 2 to the 3, because you divide the 6 by this, and you get 2 to the 3 times the square root of 2, and 2 to the 3 is 8. So this would just be a long way of doing it. If you can see 64 as a perfect factor of that, you can jump right to the answer. Okay, the sum of the squares of the legs, b squared plus 6 squared, is equal to the sum of the hypotenuse. So b squared plus 36 is equal to 81. So b squared is 81 minus 36, which is 45. So b is equal to the square root of 45. 45 is 9 times 5, and I'll write it like that because 9 is a perfect square, and we can square root it and take it out. So this ends up as 3 root 5. Okay, the square of the sum of the square of the legs, so a squared plus 5 squared, is the square of the hypotenuse. That means that a squared is 81 minus 25, 76, that's 56. So a is equal to the square root of 56. Now 56 is 2 times 28 and 2 times 14. This is 2 squared. And I can take out the 2 squared by square rooting it, we just get a 2. So this is 2 root 14. Notice I didn't bother to factor this any further because I know that's just 2 and 7, but I don't get a perfect square when I factor that, so I didn't bother. That's the answer. Okay, the sum of the square of the legs, so we have a squared plus 7 squared is the square of the hypotenuse. 11 squared is 121. So a squared is equal to 121 minus 49. So it looks like 72. So a must be the square root of 72. 72 is not a perfect square, but 36 is, and 36 is a factor of this. So I can rewrite this as 2 times 36. And then I'll square root the 36, but take it out, and that'll become a 6. So my answer is 6 root 2 because the 2 is left behind. All right, the distance between 2 points, we're going to use this formula, that d is equal to the square root of the difference of the x's, so x2 minus x1 squared plus the difference of the y's, so y2 minus y1 squared. So this is equal to the square root. x2 is the x value of the second point, so that's 1, minus x1 is the x value of the first point, so that's 6 squared, plus y2, which is the y value of the second point, that's 1, minus y1, which is the y value of the first point, that's 13 squared. This is equal to negative 5 squared plus negative 12 squared, which is a positive 25 plus a positive 144, which is the square root of 169, which comes out to exactly 13. Okay, again, the distance formula is right here. We're going to use that in each of these types of problems. So this is the square root. x2 is the x value of the second point, so that's 2, minus x1 is the x value of the first point, so that's 8 squared, plus y2, which is the y value of the second point, that's 5, minus y1, which is the y value of the first point, that's 13. So this is square root of negative 6 squared plus 5 minus 13 is negative 8 squared, which is the square root of 36 plus 64, which is the square root of 100, and we get 10. Okay, the distance between these 2 points, again, I'm going to use this formula, and that so the distance is going to be equal to the square root of x2, which is 3, minus x1, which is a negative 6 squared, plus y2, which is negative 4, minus y1, which is 5 squared. This is going to be the square root of 3 plus 6, which is 9. Negative 4 minus 5 is negative 9. So we'll get 81 for both of these. Oops, what did I just do? Which is 162, which is the square root of 81 times 2. And we can take out the 81 by square rooting it and get a 9. So we're going to be left with 9 root 2. Okay, number 114, we're going to use the distance formula, which is there. So this is going to be equal to the square root of x2, which is negative 7, minus x1, which is a negative 1 squared, plus y2, which is a positive 7, minus y1, which is 5. So this is going to be equal to negative 7 plus 1, which is negative 6. 7 minus 5 is 2. So this is the square root of 36 plus 4, or the square root of 40. I'm going to simplify the square root of 40 by writing it as 4 times 10, because 4 is a factor of 40 and it's a perfect square. So we'll take it out by square rooting it and get a 2. So we're left with 2 root 10. Okay, we're gonna use the distance formula, which is there. And so this is equal to the square root of x2, which is the x value of the second point, minus x1, which is the x value of the first point, plus y2, which is 1, minus y1, which is 2. This is negative 4 plus 8, which is a positive 4. This is 1 minus 2, which is a negative 1. So this turns into 16 plus 1, which is the square root of 17, and that cannot be simplified. Okay, here we have 2 points, and our points have radicals in them. We'd still do the same thing. So we're going to use our formula, and that's there. And then so this is going to be equal to the square root of x2, which is the x value of the second point, so negative 2 root 2 minus x1, which is the x value of the first point, and we're going to square that, plus the y value of the second point, which is that 4 root 6, minus the y value of the first point, which is root 6, and we'll square that. So this is going to be equal to the square root. Now these are like terms, so we have negative 2 minus 1 is negative 3. These are like terms, so we have 4 minus 1 is positive 3. Now, when we square, so this is still in a square root. When we square this, we got to square both parts. The square of this is positive 9. The square of this is 2. We have 9 times 2, which is going to become an 18. And when we square this, we get 9. When we square this, we get 6. So we have 9 times 6, which is going to be a 54. So we have 18 plus 54, which is the square root of 72. We're going to simplify it by writing that as the square root of 36 times 2, because 36 is a perfect square and it's a factor here. So now we can bring this out by square rooting it and get a 6. So we'll be left with 6 root 2. Okay, again, we're going to use the distance formula, which is there. And so this is going to be equal to the square root of x2, which is negative root 7, minus x1, which is root 7. We're going to square that, plus y2, which is 4 root 3, minus y1, which is 9 root 3. Here we have negative 1 minus 1 is negative 2. And here we have 4 minus 9. Because these are like terms, we're combining them. 4 minus 9 is negative 5. So now when we square, here, this is all still in the square root. When we square this, we're going to square this, and that's a positive 4. We square that, and we get 7. When we square this, we get positive 25. When we square this, we get 3. So this is equal to the square root of 28 plus 75, which is a square root of 103. And that cannot be broken down any further, so that's our final answer. All right, here's our distance formula. So this is going to be equal to the square root of x2. Now, all of this stuff is the x value of the second point. So x2 is x minus y, minus x1, which is the x value of the first point. So I'm going to have to put that in parentheses, and I'm going to put x plus y there, and then I'm going to square all of that, plus y2, which is the y value of the second point, so that's x, minus y1, which is the y value of the first point, so that's y squared. Well, this is going to distribute, and I'm going to get x minus y minus x minus y squared. Oops, I forgot to close my parentheses there. So I have x minus y quantity squared here, which is equal to the square root of negative 2y. That's because the x's go away, but I have negative y, which is negative 2y squared plus x minus y squared. This is getting kind of silly, but this becomes a positive 4y squared. And then this, we're squaring a binomial. So when you square a binomial, you always square the first term, that's x squared. Then you go twice the product of the two. The product of these two is negative xy, so twice that is negative 2xy. And finally, it's the square of the last term, so that's a positive y squared. And finally, let's put it here, we're going to combine any like terms. The only like terms we have are 4y and 1y squared. So that's going to be 5y squared. But the rest we can't simplify. So plus x squared minus 2xy, and that's it. Okay, so let's do this. Move that up there. All right, so this is equal to the square root of x2, which is the x value of the second point, that's d, minus x1, which is the x value of the first point, that's c. Oops. And we'll square all of that, plus y2, which is the y value of the second point, so that's c plus d, minus y1, which is all of that. So I'm going to have to put that in parentheses. So I'm going to say equals minus c minus d, and then I'm going to close that and square it. And this negative is going to distribute. So we're going to get the square root of d minus c squared plus, I'm going to have c plus d minus c minus or plus d, all of that squared. So this is going to be equal to the square root of d minus c squared plus, now the positive d and the positive d add up, but the c minus c goes away. So this is going to be 2d quantity squared. This is a binomial, and when you square a binomial, it's always the square of the first, which is d squared, times twice the product of the two. The product of the two is negative cd, so twice that is negative 2cd, plus the square of the second, plus c squared. And then when we square this, we get 4d squared. And finally, I'm going to combine like terms. D squared and 4d squared are like terms, so that's going to be the square root of 5d squared. And then this stuff we can't do anything with, so we just got to write it down. Minus 2cd plus c squared. And that's it. Okay, so Pythagorean's theorem this is a right triangle. That's a square, right angle there. So the sum of the squares of the legs, so 21.7 squared plus 16 squared is equal to the square of the hypotenuse. I'm going to use a calculator. 21.7 squared is 470.89. 16 squared is 256, is d squared. So this adds up to 726.89. So d must be the square root of 726.89, which is, just using a calculator, 26.96. Now it says to round to the nearest tenth of an inch. Well, here's the 1/10 of an inch spot. So this tells us we're going to round it up. So this is going to be 27.0 inches. That's this distance here.